So hello everyone, in this video we are going to discuss about the one more component required in the embedded film, that is the oscillator circuit and the real-time clock. So in this one, a microprocessor or a microcontroller is a digital device that made up of a digital combinations and the sequential circuit. So digital components like sequential circuits. The instruction execution of the microprocessor control occurs in the synchronized with the clock signal. So instruction will be execution. The microprocessor or a controller occurs in the synchronous with the clock signals. So execution part, how the execution is done. Already you know that the fetching, decoding and execution. This is a process of execution, the pipelining process in the microprocessor. So fetching means fetch the data from the memory location first. So it needs a clock signal to fetch the data. After that fetching, the data is coming into decoding. Decoding is converting into in the form of ones and zeros. Then again converting into execution process. After the decoding, there is a execution is running on. So all these are synchronized with the clock signals generated by the crystal oscillator in a microprocessor controller. Oscillator unit is responsible for generating the precise clock for the processor. Precise clock for the processor. So basically, the embedded system and inbuilt oscillator unit is there. So inbuilt oscillator unit are external crystal generator is required for the clock signals for the processor array controller. The logical circuit in the processor set in upper threshold level of the clock frequency. That is the most important, the logical upper threshold of the processing. And the beyond which system becomes the unstable state. It is in unstable state. Yeah, the accessory of the clock signal decides the execution of the program. So the accessory of the clock signal is decides the execution of the program. The oscillator circuit using the crystal or quartz crystal oscillator using in the microprocessor and a microcontrollers. So in the power consumption is directly proportional to the clock frequency. It is necessary to maintain the proper clock frequency for the approaching the functioning of the system. So certain processor or the controller integrated build of oscillator circuit unit simply requires an external or crystal for providing the necessary clock signals. So the generation of the clock signal is depending of, it indicates the speed of the processor or the controller. So I have to take best example how to take in 8051 microcontroller is there. I have to take some example of 8051 microcontroller that it generates 11.059 megahertz frequency. It generates the clock processor 11.059 megahertz. So coming to the Arduino board, you have to take the inbuilt, there is a crystal oscillator is there. It generates 16 kilohertz. 16 kilohertz. So the speed operating speed is 16 kilohertz. So this is coming to the microcontroller, that is 8051 is 11.059. So these are the different types processor and controller clock frequency. The speed of the operation of the processor is primarily depending on the clock frequency. This one is only clock frequency. How the clock pulses are generated based on your oscillator circuit. So the total system power consumption is directly proportional to the clock frequency. The system power consumption is directly proportional, not inversely proportional, or directly proportional to the clock frequency. The power consumption is high, automatically the clock frequency also be high. So based on both are working on both are working on the directly proportional only. So this is about the oscillator circuit and the use of the oscillator circuit in the your embedded system firmware external component. So coming to the next one, that is a real-time clock. So real-time clock, RTC is a system component responsible for keeping the track of time. it holds the information like current time in hours, minutes and seconds in both 12 hours format or 24 hours format, and date, month, year, by the week, etc. This is supply timing reference to the system. So timing reference to the system. RTC real time clock is in intended to function even the absence of the power also. So in suddenly power off condition is and power consumption is low, or power is some power interruption is there in your at that time, this is also working at that time also, this is working. So this is about the real time clock. A system component that holds the time date. It contains the microchip that provides the timing reference to the system, even the absence of the power also. Absence of the Even the absence of the power also. Embedded system OS device are synchronized to OS kernel operation using the time reference. So this real-time clock is using for the embedded system OS operating system device are synchronized to the OS kernel operations reference, and RTC interrupts OS kernel by generating the interrupt signals on interrupt controller. So this RTC real-time clock interrupts an OS kernel by generating the interrupt signals in the interrupt vector table or interrupt controller. This OS kernel identifies the interrupt request IRK that performs operations like date, time, updating the adding software timings, etc. Means in this one in this real-time clock there is a time, date, and date there is an format is not there, means that today time and date is not sitting in the proper way. You have to run the program and execution time, it indicates there is a time and date is not in proper manner. Again, you have to observe in this one real-time clock is in the normal systems also. You have to observe, you have to open the internet browser. At that time the time clock is not in the set mode, automatically it shows that the clock error is there. At the time of your browsing time, it indicates clock error is there. Clock error means it requires how to change the clock to real time right now, then how to execution process is done. So automatically the operating system is running in the manner also at the time of executions and browsing these type of situations are occur. Master should how to maintain the time at uh, time how to maintain the time how to maintain the proper time in the real time clock. So one more circuit also required for the external component, that is brownout protection circuit. So in this embedded system the brownout protection circuit is used to protect the processor or a controller program execution when the operating voltage drops below the threshold level. So operating voltage is below the threshold level, automatically the brownout protection circuit is uh, used to protect the processor array controller. So automatically the power down consumption time this one is using. The voltage level is below threshold. The result of the data corruption, it becomes difficult to predict the behavior of the circuit. So this is also a inbuilt in the brownout protection circuit also inbuilt in the microprocessor, the controller and embedded system components. Also, this is about the what is the need of real-time clock in the embedded system and what is the need of oscillator unit in the embedded system. Thank you.